So in this video we're going to introduce division with fractions on the Roman abacus and counting board, and we're going to use some techniques we've been using in the Reading Ancient Schoolroom. This video presupposes our videos called Introduction to the Roman Abacus and Counting Board, Multiplication on the Roman Abacus and Counting Board, Division on the Roman Abacus and Counting Board, and Introduction to Fractions on the Roman Abacus and Counting Board. So you might like to watch those videos first. Now, fractions tend to come in when we're doing division if the number we're dividing by doesn't go exactly. And we had an example of this in our video on division when we were dividing 38,692 by 215. Those are the numbers we've got written here on a piece of papyrus. 38,692 divided by 215. We got an answer of 179 with a remainder of 207. We did the sum on two counting boards. Actually, we did it a couple of ways, but if you think when we did it on two counting boards, we were building up our answer on one counting board, and that answer was 179. And on the other counting board, we were left with a remainder of 207. And one thing you could do when you get to this point is to say perhaps that's good enough, depending on why you were dividing 38,692 by 215. Perhaps it's enough to say the answer is 179 plus something left over. Or you could say the answer is almost 180, because these 207 are almost another instance of 215 that I could have removed from there and added another one to my answer. And there's evidence that Romans sometimes made an approximation like that. But suppose we want to get the answer as accurate as we can, given the fractions that we've got on a Roman abacus or that we've put on a couple of counting boards here. In that case, we're going to need to continue our calculation from where we left off. Here's where we left off in the other video, and get into these fraction columns on the right. And to do that, the first thing we want to do is to ask, if I divide this remainder by 215, how many twelfths can I get out of that? And to find out, the first thing I'm going to do is multiply that remainder by 12 to find out how many twelfths there are in this number 207 itself. Eleanor, what's 12 in Roman numerals?
XII.
Good, and to multiply by 12, what we're going to do is multiply by each digit of a Roman 12 individually. So we're going to first multiply by 10 for the x, and then we're going to add two lots of our number multiplied by 1 for the two i's. And now I suggest first making a mental note of 207 as the number you're multiplying by 12. Could you take that number and multiply it by 12?
Okay, so to multiply by 10, we move everything over. And then to multiply by 1, you add the original 207 twice. So here's the first lot of 207, and here's the second lot, but when I try to put the 5 on, it will turn into a 10. There.
Great, so that's how many twelfths there are in 207, but what I really want to know is not how many twelfths there are in 207, but how many twelfths are there in 207 divided by 215. And to do that, I'm going to divide this number by 215 in the way that we've been doing division, but I need to remember that what this all stands for now is a number of twelfths, and that will matter when it comes to what I enter onto this counting board to continue building up my answer over here. Now, to divide by 215, I'm going to remove sets of beans that look like a 215 on the counting board. That's two beans in the same space, one to the right next to them, and then one diagonally up to the right. So, for example, those two, and that one, and that one. Now, those beans look like a 215, but it's all shifted one place to the left. So that was a 215 times 10 that I just removed. But this time what I want to enter on this board is not a 10, but 10 twelfths, because this already stood for a number of twelfths. So I'm going to add 6 twelfths, 7, 8, 9, 10 twelfths over here. And now I can continue dividing by 215, and what I can remove now is an instance of 215 itself. Here's the 200, here's the 10, and removing the 5 will go like this. And what I want to add now is not 1 but 1/12, and that gets me to 11 twelfths in this column. That's as far as I can go dividing this number by 215, because that number is now smaller than 215. But I've got some boxes for smaller fractions over here, and I suggest the way we think about these is in terms of how many 12th parts of a 12th we can represent in each of those boxes. I've been calling this a 24th, this fraction, or half a 12th, but it's also 6 12th parts of a 12th. This one I've been calling a 48th, or a quarter of a 12th, but it's also 3 12th parts of a 12th. This one I've been calling a 72nd, or a 6th of a 12th, but it's also 2 12th parts of a 12th. And if we like, we can have 2 beans in there, in which case we would have 2 72nds, or a 36th, or 4 12th parts of a 12th. So we can have 6 12th parts of a 12th in there, 3 in there, and either 2 or 4 in there, depending if we have 1 or 2 beans in there. And if we think about it that way, what we can ask now is, if I divide this remaining remainder by 215, how many 12th parts of a 12th can I get out of that? Now this number I've got here already stands for a number of 12ths, but I want to convert it into a number of 12th parts of a 12th, and to do that I'm going to multiply it by 12. Eleanor, could you make a mental number first of what that number is, and then multiply it by 12?
So you mean a mental note, I think, and that's 119. So I take my 119 and I multiply it by 10, and then I'm going to add another 119 twice. So that's the 100. When I add the 1, this is all going to turn into another 100, and then that's the 9.
Great.
And then my second 119, there's the 100,
Great.
there's the 10, and when I add another 9 here, I'm going to get that. Am I right?
Yes, great. And now what we want to do is divide this number by 215 by removing sets of beans that look like a 215. I can't remove any sets of 215 times 10 here. I haven't got a number that's big enough for that. All I'm going to be able to do is remove some sets of 215 itself. And here's the first one, 210 and 5. Now, because what all this stands for is now a number of 12th parts of a 12th, what I'd want to enter here, in principle, is 1 12th part of a 12th. But there's a small snag, because we can enter any number of 12th parts of a 12th, up to 11 here, except for 1. 1 12th part of a 12th is the one fraction we might like to use that we can't actually enter in that column. So I'm just going to make a mental note of that fraction that so far I've removed 1 set of 215. Or I could count a 1 on my fingers. Romans sometimes counted on their fingers. There's a chance that the way they represented 1 was with their little finger down, like that. It's a bit challenging to do, because I find that finger always wants to come down as well. But I'm just going to keep that finger down to remind myself I've already removed 1 set of 215. I can remove another set of 215. There's the 200. There's the 10. Removing the 5 will be a bit clunky, especially with my other hand out of action, but it can be done. I'm going to have to fill up that column, and add 1 bean up here, and then effectively what I've done is remove the 5. So I've removed a second lot of 215, and that's good, because added to the one I'm keeping on my fingers there, I've now removed 2 sets of 215, divide that by 215, and I get 2, but all this stands for a number of 12 parts of a 12th, and I can represent 2 12 parts of a 12th over here. Eleanor, how would I do that?
By putting a bean here.
Great, and I can release that finger now, which is good, and now I can carry on removing some sets of 215. There's another one. Can I now adjust that so I've got 3 12th parts of a 12th?
Would that do it?
Exactly, that would do it, because that now represents 3 12th parts of a 12th instead of 2, because I've removed one more over here. And I can remove another set of 215. There's the 200, there's the 10, and removing the 5 will go like that. And I can now adjust that so that I've got another one. I now want 4 12th parts of a 12th on there.
Would that do it?
Super, that would do it. And I can remove another set of 215, removing 200 will go like that, and then 10 and 5. And can we adjust that so that we've got 5 12th parts of a 12th on there?
Would that do it?
It would, because we've got 3 and 2 now. And then I can remove another set of 215, that's the 200, removing 10 is the same as removing 50 and adding 40, and then removing 5 will go like that. And can I adjust that so that I've got 6 12th parts of a 12th?
Would that do it?
Great, and that's now as far as I can go, because I've got a number there that's smaller than 215. So I could say, so this is the answer plus a bit left over. Or I could say, well, actually, if I think about this number, that's actually more than half of another 215. It's closer to being another 215 than it is to being nothing. So if I want to get the most accurate answer I can, representing it on here, what I really want in this column is not 6 12th parts of a 12th, but 7. Can you adjust that so that we've got 7 12th parts of a 12th in there?
Well, that would be 3, and that would be 4.
Great, and that's our answer as accurately as we can get it with those fractions. And what is that answer?
179 and 11 twelfths and 1 48th and 1 36th.
Excellent, and that brings us to the end of this video. This is who we are. Thank you for watching.